This video is about cap theorem in a very simple way and easy to remember. I spent few hours learning about cap theorem from different sources on internet like blog, videos, AI and whatnot. So I want to make this video to make it easy to understand about cap theorem with a very simple and easy example. So let's start right away. We have partition tolerance, and in a distributed system we have multiple systems communicating to each other, and sometimes network failure can happen. Sometimes the system needs to update or the application is down in one system. Anything can happen. So in that case, two of our system cannot communicate to each other. For example, this link is broken. Now this and this system cannot communicate. This can happen. So that is partition. So partition tolerance say that if partition has occurred in our system, do we tolerate it and still serve the user? We of course want that. We don't want that if one system is not able to communicate to the other, that we stop the whole system and stop serving user. We don't want that. So of course we want partition tolerance. The other thing that we have to choose is between consistency and availability. For example, in a banking system, we have two systems, ATM machine and a mobile app. Whenever there is a transaction at ATM machine, we also want it to be instantly reflected in mobile app. And that is where we have to consider the consistency of two systems. For example, there is a network partition between these two systems and they cannot communicate, then consistency is suffered. If the ATM has transaction, then the mobile app cannot reflect it. So we don't want that. In that situation, we are choosing consistency over availability. Now we say that if the system cannot be consistent, make it unavailable, so availability suffers. We say to users that the system is down, make a transaction maybe after some time. So we chose consistency and partition tolerance over availability. And you have often seen this in real life as well. Sometimes banking systems are down because we do not want to be inconsistent. We can be unavailable for some time, but we want the consistency every time. Now, in case of social media, let's say there are two systems, post and comment, which both are connected right now. So let's say the system underwent a partition, the network is not available, so these both cannot communicate to each other. In that case, if somebody is commenting on the post, then the number of comment on the post will not increase. But still we want to be able to say that the people can comment on that post, and that is what we chose, availability. And when the system is again up, when they are connected to each other, then the post will update and reflect the actual number of comment. That doesn't cause a disastrous effect, which was in case of banking. If the user sees a little while later that the number of comment is not 3, it's 4, for example, then that doesn't make an effect. So we choose availability over consistency. We want the system to be always available. The user should be able to always comment. Later on we can reconcile them and show the actual data. So now let's recap everything. In a distributed system, we have multiple systems connected to each other. If there is a network failure, for example, then two systems cannot communicate. In that situation also, we want the user to be able to access our system, and that is called partition tolerance. If there is a partition, we tolerate it and keep serving to users. And after that, we have to choose between consistency and availability according to our need. So if we choose to be consistent, then we want that these two systems should be able to communicate to each other and be consistent on data. If that cannot be ensured, then the system will go down, and that is availability suffers. So we chose consistency over availability. Now, in the other case, for example, social media, we want the system to be always available. We don't want the consistency right away. The system can reconcile later and consistency will eventually occur. So this is all about cap theorem. Hope you understand it, and see you in the next one. Keep watching.